Okay, so we're going to try something completely different for you. So last year you learned about transformations. And transformation is just movement. So you translated it, you just moved it back and forth or up and down. You dilated so it got bigger or smaller. And then in this case, you have a positive and negative. So it'll make it either your parabola going up or down. So a couple things that you need to know here. First of all, standard form. We know that's ax squared plus bx plus c. So a parent form is where my vertex is going to be at 0, 0, is basically y equals x squared. Now, what that means is that's your basic before we add any of these things. Okay, so everything that we add here, here, or here is going to move this thing. They have what's called your vertex form, and that's here. And a couple of things you need to know. So our A is our A. Our B is basically your H. And our C is always that constant. So if you want to think about it kind of as your standard form, you can think of it, but they changed these as H and K because we're now in what's called a vertex form. So it's just a different look. So these things are going to change what your basic parabola looks like. Now, since this is the negative, minus, that means it's the opposite of whatever this is. So again, opposite of whatever this is. And we've seen this time and time again. They always want the opposite of this. And then your C is that constant. Okay, so your vertex. So if I was given this in this form, I can see that vertex immediately. I know it's going to be the opposite of this and then whatever that value is. And we'll see that. Okay, so this A tells us if it is negative, it's going to go this way. If it's positive, it's going to go that way. That's it. That's super easy. So if this is negative or if this is positive. Now, whatever's in this parentheses, it's going to go the opposite direction. So if this says negative, it's going to go to the right. Your movement is to the right. If it is positive, because it's the opposite, it's going to move to your left. This guy at the end is easy because that's going to tell you whether to go. If it's negative, you're going to go downwards. And if you're positive, it's going to go up. So that one's the easy one. Okay, let's confuse this a little bit more. Now, A is narrowly stretched if it's greater than 1. So if your A is greater than 1, then you're going to be like, I don't know, Stretch Armstrong. Okay. If your A is less than 1, or a fraction is what that means. If you end up with a fraction, it widens. It will widen. Okay. They call that compressed because it's pushing down, it's making it wider. This one's narrowly stretched because you're pushing against this way, kind of. This you're pressing against that way. Anyway, and the way I kind of remember those, and I've said this before, if, the steeper it is, so if you went 5, if your slope or your A is positive 5, that means your slope is going up 5 over 1. So that's pretty steep. And here, if my A is like 1/5, you go up 1 and then over 5. So you can see how stretched that is. Like, I'm not stretched, but wider. So that's kind of what that's telling you. Okay, so translations that involve H and K. So translation, that's just your move. Left, right, up, down. Your A will tell you whether it is super stretchy or whether it's wider. It also tells you whether it is up or down. So those are the translations. All right. Sometimes you need to rewrite them to understand them. So if you see this, which is kind of in standard form, again, here's your A, and this is your C. In our case, let's just remember that Y, I think this is helpful. A is still your A, but when you see this, so somebody would call this H and K. I think that might help. Might want to highlight that or star that. Okay, so let's put this baby in action. So watching a video that you did on Desmos, it kind of shows you, or that you're going to watch on Desmos, you're going to see how these things affect your A, H, K, or your A, B, and C. So again, I like to put the B here and the C here, just so you have a point of reference. Okay, so now we're going to look at this equation. You have a 1 here and a negative 10 there. If we put this in vertex form, this is standard, we would write it 1, because that's my A, x minus our B, because there is none, and then this is my C. What is this telling me? So my translation is my H and K. So do I have, and you can put the H and K here too, and this is my A. So my translation, I have nothing here that tells me to go left and right. Okay, so this guy horizontal goes left or right. This guy goes up and down, and this is always the opposite. Can't say that enough. Can you see what I'm doing up there? Hopefully, yes. Okay, so I don't have an H, but my K means I am going to go downwards 10. My dilation has to do with my A. My dilation means, is it going to be wide, or is it going to be super narrow? So whether it's going to be wide or narrow. Now my A value is 1, so it's going to stay the same actually. So there is no dilation since it's 1. And this was negative 10. We might want to put that. My reflection is easy. So is my A positive or negative? My A here is positive, so it's going to go up. That's it. So we're just seeing what happens to these things. So we're going to rewrite this too. So again, here's my A, here is my C. So we're going to try to put it into that formula. So my A is negative 3, x minus 0, because we don't have a B, squared minus 8. My translation, again, is my H or K. Here's my H, K. So I have no H, but my K says to move down 8. That constant is always super easy. It's always your y-intercept as well. Don't forget that. My dilation has to do with my A. Since it's negative 3 or 3, we'll just say 3, that means it's going to stretch. Stretch. Reflection. Since it is positive or negative, it is negative, then that's all we need to know. Okay, it's going to go downwards. Sorry, that stretch is kind of misleading. Next one. Ooh, we're going to go to standard form. So really, this is my A. Sorry, can you see? A. This is my B. We have no C. So I'm going to rewrite in standard form. So y is equal to 1/2 x squared, just because I want you to understand where these values are coming from, plus 1x, and then that's it. So h and k, this is also my h. That means I'm going to go to the opposite. My h is equal to 1. That means the opposite. So you go left 1. No, that one's a tricky one. The reason being, actually, this should be a negative. Let's change that. Okay. Your dilation, that has to do with our A. It's a fraction, so it's a half, even though it's a negative half. A half, so that's going to be wider. And is it a negative or a positive? It is a negative, so it's going to go downwards. Next, again, I want you to rewrite it in standard form. So I have no A, this is my B, and this is my C. And remember, this is always the opposite. That's going to be so hard to remember. So y is equal to, I don't have an A, so we're going to make it a 1, x squared, opposite, so plus 2x plus 1. Translation has to do with, and maybe when you do this, you can actually see this as positive and not the negative. That might help you. That's the reason why I'm doing it. So your h and k. So I do have an h, so the opposite means I am going to go positive 2 or to my right. Opposite. And here you can see that it's positive. And then I'm going to go up 1 because of this. Okay. My dilation, my A, nothing's going to happen because my A is 1. And that means it stays the same or none. My reflection, is it positive or negative? My 1 here is positive, and that's it. All right, so which is an equation for the function? So if I'm looking here, so if this was my parent, your original always starts. So y equals x squared will always start here. I do know I moved down 2. So it's got to be negative 2. So this can't be right and this can't be right. The other thing I can see, because when you move up and down, that has to do with this C, right? The other thing I can see with this is that it's going upward. My A is positive, since this graph is going upward. So my A is positive. So it has to be this one. Also, you can see that this is wider, so it has to be that fraction. So there's so many things that'll help you with this one. We can rewrite these real quickly. So y is equal to 3x squared, x minus 0 squared, and plus 2. Rewrite this one. Y is equal to negative 1/3 x squared. Again, x minus 0 squared plus 2. And that one's already written. So down 2, spread wide, positive. Just a few more. I know this seems like a lot, and we're going to spend a couple days on this. I really love these. Take a break if you need to, if you're doing this online or looking at this again. But let's take a look at this one. So what do we know? It's going downwards. So downwards means my A needs to be negative. So I'm going to mark off that one and mark off that one. I also moved my vertex up 1, 2, 3. So I went up 3. So plus 3 has to be this one. Okay. Look at this. List the function in order from the most vertically stretched. So vertically stretched means a whole number, biggest, I don't want to say biggest number. I don't want to put whole. Let's just put biggest number is going to be vertically stretched. So if I look here, here, and here, most vertically most vertically to the least vertically stretched. So my highest, I don't want to say the biggest number, the biggest, because it's almost like your absolute value, meaning the distance from zero, furthest from zero. So the ones furthest from zero is this one, then this one, then this one. This one is a -1. That's a 5/3, so that's 1 and something. And this is -4/5. So even though this is a negative, this is going to be furthest from zero, then this one, then this one.